Hello everyone, and welcome to the part 5 of my C programming tutorials. I have just brewed a cup of coffee, so we should be ready to go. So in the previous video, we were looking at pointers, and we also looked at the malloc function to allocate memory. Today I want to introduce functions, and we're going to combine functions with pointers, with what we learned from pointers, basically. So, first I'm going to create another folder here called part 5. And we're going to create a main.c. And we're going to write our usual main function here. So, main int argc char arg v. And we're going to return 0 to tell everyone that we're doing fine. We're going to include stdio.h to be able to print things. That's very helpful. And we're going to want stdlib.h to be able to allocate memory. Okay, so functions. Let's say we want to define a function here. We're going to start very simple, okay? So first, maybe we want to create a function that just returns an integer. Why not? So to create a function, you basically just type the, well, you actually already know how to create a function, because this is a function that we have created. So the same syntax goes for when you want to create other functions. So let's create our integer function here. So we're going to call it, it's going to have the type of int. It's going to return an int, okay? And we're going to call it add. So it's just going to add two integers. So let's do int a, int b. So whatever you put inside the parentheses here are the arguments that the function takes in. And whatever you return is what this function will give you when you run it. So in this case, we want to return a plus b. That's all this function is going to do. So let's try this function out. So let's do int result is equal to add. So now we're calling our function. And to call a function, you just specify the name and parentheses. And our function takes 2 arguments. So let's give the function 2 arguments. Let's do 5 and 6, okay? And then we're gonna print the result. So printf %d for digit, new line, and we're gonna print result. Then I'm gonna go into the part 5 folder. I'm gonna run gcc main.c, and that generated an a.out file. So let's run that, and we can see our result here. Cool. So let's make a little bit more complicated function. We want to have a function that that gives us a pointer. So what kind of function are we going to define? Well, let's write a function that gives us a pointer to a char array. That could be pretty useful. So this is a function that's basically going to give us a string. But remember, strings aren't a part of C, they are char arrays. So what we can do is do Char Pointer. So what this means is that we're pointing to somewhere in the memory where there is a character, but we have a size as well. So it's going to point to, the pointer is going to point to the beginning of a couple addresses. And the number of addresses is equal to the size we define. So that makes it a char array, basically. So let's just call it get string. And maybe we can specify how big string we want. So to do that, you can use a data type called size_t, which is basically an unsigned integer in most cases. And we can say length. How big should the string be? So what we can do is first allocate some memory, right? And we did this in the previous video using malloc. Now there is also another function called calloc, which allocates the memory and also sets all the bytes to 0, which is actually what we want. Usually you can get undefined behavior in your program if you pass around pointers with undefined data in it. So it's usually a good practice to have them be zeroed out. So to do this, we can do char myString is equal to calloc. Now calloc takes 2 arguments. And the first argument is basically a length, so we can just pass in length here. And the second argument is like a multiplier. So in here we can just pass in size of char. Okay. And this is basically the same thing as doing char myString is equal to calloc or malloc length times size of char. But calloc actually sets all the bytes to 0 for us. So there we go. Now let's just return myString. And let's try and use it. So we can do char pointer string is equal to get string. And how big string do we want? Well, let's just type 16 or something. And let's print string. %s for string. / new line string. Let's compile. Run it. And we're seeing nothing, because all the bytes are 0. So how can we make it actually contain some data? Well, since this is a char array, myString is a char array, we could just manually put data into it if we want. So we could do myString position 0 is equal to A. So now we're manually putting a character at position 0. So if we compile this and run it, we're seeing the letter A. And since we're having the length of this string is actually 16, so basically we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're going to have 16 bytes in there, and the first byte is going to contain an A, and the rest ones are going to be 0. And we have also specified that all of these elements in this array has the size of char, and so basically I think the size of a char is 8 bits, if I remember correctly. So each element here is going to have anyway, let's not go into that, that's too complicated. But anyway, this is basically what our char array here looks like right now. Now, if we want to, let's say we want to put something, let's say we just want to copy in another string into this string, then we can use something called sprintf, which takes in the first argument is the string we want to put copy in the string to. The second argument is the string, like the template that we want to use, and we just want to use %s. And the third argument is what we want to format this string here with. So we can just put hello. And we know for sure that this is going to work because hello is less than 16 bytes. So hello will fit fine into this pointer here. So if we compile this and we run it, we're seeing hello here. Cool. And another thing I want to show you is combining a function with a struct pointer, so we can create a function that actually gives us a struct. So the way we can do that is first we need to define a struct. So we can do type def struct, and we can call it let's call it person t. And the reason why I put _t here is just to it's not necessary at all, it's just what I decide to name it, and I put _t here to tell myself, my future self, that this is a type. So T stands for type. And maybe a person has some fields in it. Maybe it has a age, an integer age, and maybe it has a string, a char pointer of name, and that's all our person is going to have. Now we can create a function that allocates memory for this struct and gives us a new struct. So what we can do is person t pointer. We're defining a function here now. Let's call it new person. So this function here is going to create a new person, a new struct of this type. And maybe it takes in some arguments here. So, okay, how old are you? Int age. What's your name? Char name. Now, this second argument here, char name, is a variable that we never want to be modified. When we pass in that argument to the function, it's a constant variable, right? So in this case, it makes sense to name it const, or to use the const modifier here. This is a constant. The function shouldn't modify that. Okay. So now we're going to allocate some memory for this person here. So we can do person t person is equal to calloc. We only want one person, right? So one person, size of person t. So we're allocating one person, or one piece of data with the size of person t, the size of this struct. Okay. And since we're taking in some arguments here, we should probably put that data on this person that we have generated. So we can do person age is equal to age. And by the way, since this now is a pointer, you no longer use dot to access fields within it. You use the arrow sign, okay? So person age is equal to age. Now, here's a tricky thing. You can't do, and you shouldn't do, person name is equal to name. I mean, you can do that, but it's going to cause complications, and you might actually experience undefined behavior later if you're creating multiple persons. Because this thing here is always going to point to the same data, and that thing here is actually going to be allocated in the heap, and depending on if you call this function directly and put the string in there directly. So what I usually do here, instead of just doing person name is equal to name, is that we actually allocate memory inside of this struct for this string once again, so that it gets a new address, a new pointer basically. So what we do is person name is equal to calloc strlen, and strlen gets the length of a string basically. So we want the length of the name that we passed in here, and we're actually going to do +1. And the reason why we do +1, because strings in C, they should always end with a null termination character. So for example, if we have the string hello, the system needs to know where the string ends, and a solution for that is a null terminated character at the end. So we want to have memory, or we want to be able to fit this null termination character inside of there. So that's why we do +1. Okay, and then the second argument is size of char, because remember, it's a char array. It's an array of chars, and in this case it has the length of the name +1. Now what we can do is just copy the contents of this string here into this string. So we can do that by using string copy, strcpy. And the first argument is where we want to copy it to, and we want to copy it into person name. And the second argument is the string we want to copy. So we want to copy name in this case, okay? So now we have successfully copied the contents of this variable here into the pointer char name in the struct. And now we're ready to return person. Cool. So how do we use this function? Well, we do person t person is equal to new person, and maybe his age is 23 and his name is John. And if we compile this now, we're probably going to get some errors. And yes, we're getting errors. It wants us to include string.h because we're using strlen and structcopy, and those functions are defined in string.h. Let's compile that again and run it, and it executes successfully. So maybe we want to print the contents of this person here. Maybe we want to print printf digit person age. And there we go, we got its name. And maybe we want to print the age. Maybe we want to print the name as well. Then we do %s, and we add the person name as an argument. And there we go, 23 John. And you can call this function here how many times you want. We can even put it in a loop if we want. So for int I is equal to 0, if I is less than 10, we're going to create 10 persons, I++. And maybe for every iteration, we're going to add I to the age. So now if we print f age as a digit and name as a string, new line, person age, person name, we're gonna see 10 persons being printed out. So let's compile it and run it. There we go. and the age is incrementing. So there we go. Now we have learned how to create functions and how to combine them with pointers. And yeah, you can do a lot of things with that. I hope we learned something today. If you haven't seen the previous video, I'll put that in the description, and also the full source code to this is also in the description. And I'll see you next time.